Welcome to lecture number 24, and in this lecture we will be studying high level knowledge representation. So we'll continue the yesterday's part which is left, how to represent the high level knowledge. Yesterday we talked about how knowledge representation, what is by knowledge, and then how it is represented in computer vision and AI. So in that also we studied about low level representation and the high level representation of the knowledge, which can be used further for recognition purpose or identification purpose and so on. So in the low level part, basically we extract the features based on the low level features like the textural feature or shape feature or color feature. So in that we have studied several techniques for obtaining the low level features. And then yesterday I talked about high level features, and in that basically the formal grammar and knowledge, syntax and semantics and so on, and then how it is represented and so on. In this talk, I'll be talking about what is by predicate logic, and then production rules, and then semantic nets, frames, scripts, and at the end, I'll talk about fuzzy logic, how fuzzy logic is also used for representing the high-level knowledge in computer vision. Okay, so as I told you yesterday, that knowledge representation and data structures are mostly extension of the conventional data structures such as list or trees or graphs and hierarchies and set, rings, nets and matrices. So this knowledge representation is just extension of the data structure which you might have studied at the third year level of undergraduate and so on. So yesterday I talked about this one low-level features, and then where you generally find the low-level feature in terms of the numbers. Like for example, if you calculate what is the area of this object, what is the area of this object, or what is the area of this object, so you'll get some number. Or even other features like for example circularity is also a number, or elongatedness is also a number, or perimeter is also a number, and so on. And then we basically we generally extract more number of features, and then those features are arranged in a feature vector, and then after that it is given to the statistical classifier. Statistical classifier generally use the numerical features, and then this statistical classifier classifies the object into various classes and so on. So that we have studied in yesterday's talk. And also we started about the high level features like as a grammar and language, and as I told you that the whole structure or whole object is represented as a hierarchical structure, like if this is the whole structure S, and in this there are several parts, like for example S1 is this part, S2 is another part, S3, S4 and S5. Again, this S1 is also having some symbols like this one, S11 or S2, S12 and so on. And then S5 is also having some symbols like this. This symbol is represented with this one. So S5U1, which is represented as S5U1, and this is represented as S5U2. So when it is represented as a graph or hierarchical structure, so S consists of 5 main objects like as a S1, S2, S3, S4 and S5. Whereas S1 is further divided into S11 and S12. So this graph representation will be like this, and S5 is also further divided into S5U1 and S5U2. So if an object structure needs to be described, feature description is not appropriate, or only low-level features are not sufficient for complicated object description and so on. So for that, you have to go for the higher level representation of the feature, and higher level feature representation is nothing but the structural level description, and this structural level is formed from the existing primitives. As I said, that primitive is nothing but the symbols. Like see that this is one of the symbol which is representing this structure, or this is another symbol which is representing this structure. This is fifth or fourth symbol, this is third symbol, this is second symbol, this first symbol, and this part of this one will be S11 and so on. So symbols you can decide, and then the relation between all those symbols can be represented in the form of graphical or hierarchical structure and so on. So the simplest form of structure representation are either chain or trees and general graphs. So hierarchical structure can be represented by tree generally. Okay, so the whole class of object cannot be described by a single chain or a single trees, etc. But a class of structurally described object can be represented by grammars and language. Okay, so what is by grammar and language, that we'll see later on. So grammar and language provide the rules defining how the chain or trees or graphs can be constructed from a set of symbol or primitives. Okay, and then we were supposed to start tomorrow, okay, yesterday, this one. So today we'll start this part, what is by predicate logic, and then other high-level representation of the features and so on. So you know that the crisp logic is very well known. Crisp logic where you have either yes or true or false, right? True or false information is there. So this predicate logic also uses the true or false information in the basically the problem and so on. So this plays a very important role in knowledge representation. And you know that, okay, so you know that true and false is similar to the binary, either 0 or 1. So there is no nothing is in between true and false. So either it will be false or it will be true. And you know that along with this binary, you can do the operations like as an arithmetical operation can do. You can do the logical operation like, for example, ANDing or ORing operation, or not, or implies, or equivalent. And okay, so it introduces mathematical formalism to derive the new knowledge by using these operations on the given this logic. Logic is okay, so either it is a true or false information is there. So it introduces mathematical formalism to derive new knowledge from the old knowledge by applying the mathematical direction. So this works with the combination of logic variables and quantifiers and logic operators like as a and, or, not, implies, or equivalent. Okay, and you know that the logic variables are generally binary, so which is either true or which will false. So the idea of proof and the rules of inference such as modus ponens and resolution are main building blocks of predicate logic. Okay, so this only problem with this predicate logic is that it requires pure truth. Okay, either this is means for example there is a there is a fire. Okay, so either fire or there is no fire, right? Either there is a fire or there is no fire. So there is no in between, like for example smoke is there and then fire is going to start or something like that. So that things is not there in a predicate logic. Either there is a fire or there is no fire or something like that. So this requirement is, but you know that in general, in reality, you have you don't have really truth or really false, but there are several things in between truth and false. So this is basically the problem with predicate logic, because its requirement is pure truth. Okay, either it is false or true. So this represents the main weakness of predicate logic in knowledge representation, since it does not allow work with uncertain or incomplete information, but the whole world is uncertain. And then in computer vision also there are some uncertain things which you have to model with the help of mathematics. You have to do the mathematical modeling of that one. And here for uncertain things predicate logic does not work. Okay, it works only for the certain things, like either it is there or it is not there, and so on. So if the things are very clear cut, or if there is a pure truth and so on, in that case predicate logic works for knowledge representation in a computer vision, right? Then The another way of representation of the higher level knowledge is the prediction rules. Okay, you might have heard the expert systems and so on. Like for example, if somebody is developing the expert system for homeopathy doctors and so on, so homeopathy doctor asks several questions and they enter the data and so on. So if these things happen, then if these symptoms are there, then there are chances of this kind of disease or like that. And you know, okay, if you might have visited the homeopathy doctor, you might have seen that he asks several questions and then he feeds the data to the computer, and then this computer expert system is there, and then all those features are given, and then there is a prediction from that one. Production rules are also like that. So production rules represent the wide variety of knowledge representation that are based on the condition action pairs. Like for example, if condition X holds, then action Y is appropriate. So if the features are like this, then decision will be like this or something like that. So if in condition X holds, then action Y will be appropriate. So this is a rule, okay, which is developed by the experts and so on. So information about what action is appropriate at what time represents the knowledge. So this action is nothing but the knowledge, and this action depends upon this condition or these features and so on. So the procedural character of knowledge represented by production rule is another important property, okay, and not all the information about the object must be listed as the object property. Like for example, if the ball then this ball must be a circular. Okay, so you might have seen that if ball is there, it must be having a shape as a circular shape and so on. So the knowledge base, okay, you have a complete knowledge base of many things. So the knowledge base also include, like for example, to answer the question how many objects are circular. So object A is a ball and circular, object B is also a ball and circular, maybe object A is smaller, object B is larger, or okay, having medium radius and so on. So like that way, these things, okay, knowledge, okay, database is there, and then if this condition holds, then you can predict that, okay, either this ball is either object A or object B, depends upon this its diameter and so on. So like that way, the production rules works and so on. So both the production rule, knowledge representation, and production system appears frequently in computer vision and image understanding problem. And definitely here the expert's knowledge is very, very important, because okay, from the given fact you are taking some action or you are deciding something based on that one. So this is just like as a higher level, this is the higher level representation of the knowledge. You are not extracting the features like as a this one texture or shape or this color, which are lower level features and so on. But we see that, okay, if the object is circular, then this must be a ball, okay, and so on. So like that way, higher level representation is done. So production rules are also one of the way for representation of higher level knowledge in a computer vision. Then the next one for representation of the higher level knowledge is semantic nets. Okay, so what is semantic net? So it is just like as a graphical representation and then relation between this one. Like for example, if you consider the face, okay, now in the face we can see that, okay, the eyes are there, okay, lips are there, nose is there, and then you have ears and chin and so on. Then we can basically establish the relation between, like for example, this eye is to the right of this eye, or this eye is above the nose, or it is above the upper lips and then chin and so on. So you can establish the relation between all those objects within the entire scene, and then in that relation, okay, it is graphical representation. Basically, semantic net is a graphical representation along with relation between different objects within that scene and so on. So semantic nets are spatial variation or relational data structures and the semantics distinguish them from the general nets. Like for example, the semantic net consists of the objects, their description, and the description of relation between the object. Like for example, as I said, that if you are considering the face, in the face you have ears, you have eyes, you have nose, and then lips and chin, and so on. So you can establish the relation between all those objects within the face. So if you consider the face as a complete scene or complete object, within that object you have several objects, and then you are establishing the relation between them, and then that can be represented as a semantic net, as a graphical representation or a relational data structure, and so on. So logical forms of knowledge can be included in a semantic net, and a predicate logic can be also used to represent and or evaluate the local information and the local knowledge. So semantic net can also represent the common sense knowledge. Okay, so here we are not extracting that color shape or texture, but we are using the common sense of the knowledge representation, and then that will be very useful for higher level representation. So that is often imprecise and needs to be treated as a probabilistic way, and so on. So semantic nets have hierarchical structure. Complex representation consists of less complex representation, which can in turn be divided into simpler ones by dividing the entire scene into different regions, and so on. So relations between the partial representation are described at all the appropriate hierarchical level. Look at this one. See, this is the example which I was talking, like the semantic net for the human face. Like for example, this eyes, like for example, eyes is a circular. Okay, so that information is there. This is left to the left. This is also eye, so which is to the left of this eye. So this relation is left. This eye is to the left of this eye. Okay, this eye is being a circular. Okay, this is also being a circular. And then okay, you are establishing the relation between eyes and nose. So you are establishing the relation between nose and eyes. So okay, see the arrow between this one nose and a left eye. So this nose is below the eye, also this is below the eye, and then this is left of this one nose. Okay, here it should be right off. Okay, it should be a right of nose one. It should not be left. Okay, and then see that nose itself is okay also explained with a graph like as a being vertically elongated, and then okay you have this lips which is just below the nose and being horizontally elongated, and then okay you can have the relation with your ears also being a circular, or this within inside your this one mouth, okay, inside your whole face, and so on. So like that way you can establish the relation between the object, and it can be represented as a relational data structure okay, in a computer vision. So semantic net is very, very useful for representing the complex things or complex scenes, and so on. And then after that, at the end, these frames and scripts. So frames and scripts are also used as a higher level representation, higher level knowledge representation in a computer vision. So you know that script, okay, just imagine that for movie there is a script, right? So from the script, okay, movie is developed, and so on. So in a computer vision, okay, it is sometimes similar to the film scripts also. Like, so frames, basically what is frame? So frames which are considered as a higher level representation, and this provides a very general method for knowledge representation, which may contain all the knowledge representation principles, like whether it is a predicate logic or production rules or semantic nets. So this frame consists of all those okay, combination of all, right? And is suitable for representing the common sense of knowledge and under the specific circumstances. So you can say that frame is a combination of knowledge representation, like as a production rules or predicate logic or semantic nets or syntax languages and so on. So it is a combination of all those things. Okay, sometimes this is also called as the script because they are because of their similarity to the film scripts and so on. So for example, consider the frame called as the plane start. So when you would like to start the plane, so which are the following which are the sequences which are followed? So the which may consist of the following sequence of actions. Like for example, when you have to start the plane, so you have to start the engine. Okay, you have to take the taxi to the runaway, and then increase the RPM of the engine to the maximum before taking the takeoff of this flight and or plane, and then travel along the runway increasing the speed, and then after that it will go. So this is basically the script for plane starting and so on, so which consists of several things, like as it can be represented with predicate logic, or it can be represented with production rules, or it can be represented within this one. Okay, so within this one it can be represented as a predicate logic or semantic net or production rules and so on. So script consists of, basically frames consist of all those things, and then these are the actions for entire scene, a dynamic scene and so on. So I hope that you have understood what is meant by this one predicate logic, which consists of only zeros and one, which requires complete truth. So that is the problem. Then after that we talked about this one. Production rules means basically if certain conditions holds, then actions will be like this. If certain condition does not hold, then actions will be like this and so on. So generally this is used in expert systems and also in this one. And then after that we talked about the semantic net. So where semantic net is a graphical or relational data structure which is used in computer vision for representation of the higher level knowledge, and then we represent basically the relation between the different object within the scene and description and so on. So I talked about the semantic net of human face, and then after that I talked about the frames and scripts. So frames are script, basically it is a higher level representation and which provides a very general method for knowledge representation, which consists or which contain all those methods which are discussed, like whether it is a predicate logic or production rules or semantic nets. And then we considered about the frame called as a plain start, which are the actions. So within this one it may use predicate logic or production rules or semantic nets and so on. So like that way, this is the complete script of plain start and so on. The last important thing or way of higher level knowledge representation is fuzzy logic. So that will take this one. See that in frames or script, assuming that frames represent the knowledge of how planes usually start, the situation of planes standing on the runway with the engine running causes the prediction that the plane will start in a short while, and the frame can be used as a substitute for missing information, which may be extremely important in vision related problems. Okay, so basically frames and scripts are used generally for description of the dynamic scene analysis and so on. The last basically important way of representing the higher level knowledge is the fuzzy logic. As I told you that in predicate logic, you have either two levels, like as a completely truth or it is false, true or false. So binary system is used in predicate logic. But if you see in general world or in real world, nothing is like as a truth or false. In between that truth, there may be a partial truth or there may be a partial false, or there are thousands of membership values between 0 and 1. Okay, so fuzzy logic, which was basically proposed by Professor Lapti Zarde, from University of California, Berkeley, in around 1960s and so on. So he proposed that between, okay, instead of crisp logic, okay, we can use the fuzzy logic where there will be infinite values of membership between 0 and 1. So, like for example, 0.95 truth value is there, or 95% truth is there, or 100% truth is there, or 98% truth is there, or 10% truth is there, or something like that. So in between 0 to 1, there are infinite values which is proposed in the fuzzy logic. So between the crisp logic, say crisp logic is either having value 0 or 1. In fuzzy logic, between 0 to 1, infinite membership values are there, and that is proposed by the Professor Lopti Sade. And this is widely used in a computer vision or machine learning and pattern recognition and so on. And even in control systems also it is used for controllers and so on, for taking the smooth actions rather than, okay, on-off controller, rather than on-off controller. Generally for taking the smooth action, fuzzy logic is used. Similarly, for taking the appropriate decision, okay, fuzzy logic is used for higher level knowledge representation in a computer vision. So for example, fuzzy logic is important mechanism for handling the uncertainty information, and you know that the whole world is uncertain. So there are so many uncertain things, and for handling these uncertain things, fuzzy logic is a very good tool or very good method for representation of the higher level knowledge. And this overcomes the limitation of crisp logic or binary logic and so on, because crisp logic requires completely truth. Okay, there is no partial truth concept or in the crisp logic or like that. So for example, if the object in a two-dimensional image is considered as circular, then it may represent a ball. Okay, so there are chances that it may represent the ball or it may represent the disk also. So our experience with ball, however, says that they are usually close to but not perfectly circular. So thus it is necessary to define the certain threshold of circularity in that, like for example 0.95% circular or 0.8 this one 0.8 circularity in between 0 to 1. So if circularity is high, then object is ball with high confidence, right? If circularity is low, then object is ball but with low confidence and so on. So such knowledge representation is very close to the common sense representation of the knowledge of human being with no need of exact specification and so on. So you have to basically, when you are using the fuzzy logic, generally you have to fuzzify the data. There are several techniques available for fuzzifying the data, and then you have to develop the fuzzy rules, and then after that, once you take the action, after that you have to defuzzify the data, and then actions will be either this one on or off, or actions will be your crisp logic. Right? Yeah, it's not like that. Okay, you're going to take the this one 0.95% actions or like that. You will be taking the action or you are not going to take the action. So, but okay, for taking that decision, okay, you are using the fuzzy data or fuzzy methods for taking that decision, and a final decision will be a crisp decision. Okay, so you have to defuzzify that one. So in a literature, there are several techniques available to fuzzify the data as well as for defuzzification of the data and so on. So fuzzy rules are of the form, for example, if X is A, then Y is B, and so on. Or if where X and Y represent some properties, so X and Y are some properties, and A and B are linguistic variables which are used in the fuzzy logic. So fuzzy logic can be also used in a computer vision for representation of higher level knowledge. So if you summarize the knowledge representation, okay, for lower level knowledge representation, we are using the lower level features such as color, texture, and shape. And in higher level representation of knowledge, you can use the predicate language, grammar, or predicate logic, or semantic net, and then production rules, and so or fuzzy logic. So these are the methods for representation of the higher level knowledge, where we can use higher level knowledge representation if the scene is very complicated and difficult to do the analysis with the simple this one low level features, then we have to go for the higher level representation and so on. In case of low level features, your features are in the form of numbers, numerical values, whereas in case of higher level, it may be in the form of symbols. So symbols are considered as a primitives. So in case of lower level, you can use basically the statistical classifier for taking the decision, whereas in a case of higher level, you have to use the syntactic classifier to take the decision. So in tomorrow's lecture, or in our next lecture, we'll talk about what is the difference between the statistical classifier and syntactic classifier. And as I told you that already we have studied statistical classifier in our machine learning subject, so we'll not concentrate on that one. We'll concentrate only on the syntactic classifier and the graph-based matching technique and so on in this chapter. So this finishes the knowledge representation part of this chapter. So in our tomorrow's lecture, we'll talk about difference between the statistical classifier and syntactic classifier, and then we'll talk more about the syntactic classifier. So thank you very much. We'll stop here and see you in next lecture.